My name is Martin Rees. I'm a professor at Cambridge University, a professor of astronomy and space science. Welcome to my exp. Yes, I'm an astronomer, and I think there are four reasons we do astronomy. The first is simply exploration, to find out what's out there. The second is to try and make sense of what we see, to try and understand it in terms of the laws of physics, and to perhaps discover some new laws of physics. The third is to try to understand cosmic evolution, to understand, was there a beginning? If there was, how have things evolved from that beginning to the amazing cosmos we see around us and are a part of? And I suppose that leads to a final reason, the mystery of why things exist and why the universe is the way it is. So all these things are part of astronomy and what I do. And of course, pure thought doesn't get you very far, but thanks to improved instruments, we've made huge progress. And I would say that the last 50 years of astronomy have been one of the real highlights of science, up there with the standard model of particle physics, the double helix and all that. So I've been privileged to be part of this huge cosmic exploration. Astronomy is really a story of expanding horizons. To the ancients, the Earth was the center and the sun and planets orbited around. Post-Copernicus, we realize that we are part of a planetary system orbiting the sun. We've now realized that there are many, many other planetary systems orbiting other stars, and that our sun is just one of literally billions of stars in our galaxy, and that our galaxy is just one of many billions of galaxies that can be seen through a large telescope. And we've realized that our entire universe is a dynamic entity. Everything started off very compressed and compact, and it expanded, starting about 13.8 billion years ago, and it's gradually cooled down. Stars and galaxies have emerged, and we're coming to understand how this happened. Indeed, when I was starting my research about 50 years ago, it wasn't clear that there was a beginning, because there was a rival theory called the steady-state theory, according to which our universe had existed, as it were, from everlasting to everlasting, and although it was expanding, new galaxies formed in the gaps, as it were, as the old ones moved apart. That theory was certainly tenable until 50 years ago, and then two things happened. First, it became possible to look at objects so far away that we were looking back billions of years into the past. And in the steady-state theory, things would have looked the same there as now, but it was clear that the galaxies were different far away, and therefore far back in time than now. So the universe and the things in it were evolving. And then, even more important, evidence was found that the entire universe is full of microwave radiation coming from all directions, which can't be understood except as the afterglow of the hot beginning of the universe. The universe started off very hot and dense, it expanded and cooled, but this radiation is still around, it fills the universe, it's got nowhere else to go. And this is really unambiguous evidence that the universe had a hot, dense beginning. And later data pinned down the time of that as about 13.8 billion years ago. One thing we're trying to do is to understand how the universe evolved from that beginning to its present stage, how the first galaxies formed, how the first stars formed, and can we understand why galaxies have the properties they do and why stars evolve as they do. So that's really what we are trying to do. And I would add that one of the most exciting developments in the last 20 years has been the definite realization that our solar system is not unique. Most of the stars in the sky are other suns, and they have orbiting around them a retinue of planets, just as the sun has the Earth and the other familiar planets orbiting around it. So this is an exciting new subject, and unfortunately, these planets orbiting other stars are so faint that we can't really see them with existing instruments. But with the next generation of telescopes, we'll actually be able to study the light from planets orbiting other stars. And this, of course, leads to the most exciting question, which everyone asks me when they know I'm an astronomer, which is there life out there? We'd like to know if on these planets around other stars there could be life, vegetation, even intelligent life. It's worth a search, and within 10 years, I think we will know whether some of these planets, rather like the Earth, orbiting other stars, rather like the Sun, have vegetation and oxygen in atmospheres and other indicators that there's been biological evolution. At the moment, of course, we only know that life exists in one place, but if we could find it in a few nearby planets around other stars, that would tell us that the entire universe must be teeming with life, and that would be the most fascinating discovery of all time almost.